as you can see on the far left, is the general information. Now, in the general information, I have the first cost, which is 5,080,000, the loan, which is 1.5 million. But I wanna focus your attention on the planning horizon. I chose a planning horizon of 11 years because I wanted to see how sensitive is the decision of different loan options under different MAR values, right? And then the residual value I estimated to be 20% of the first cost, which is the first cost of all the 8 heat pumps. And for the MAR calculation, I got the WACC from the Tsogosan financial records, and the WACC data as well to be 9.7% from the Tsogosan financial records, with a risk of 4.75%. And when you add them, when I calculate my before tax MAR, my MAR value, I took the max of the WACC and the WACC equity, and then I added it with the 4.4. So that is 9.7 plus 4.75, which brought to 14.45%. Now for the loan option, it's also important to note that I chose to take out the loan with Nedbank. I chose to work with Nedbank. Now with Nedbank, a loan of 1.5 million is payable within a minimum period of 6 years. And what they do is they take a prime interest rate, and how they calculate the interest rates is the various factors that are involved. But we're going to assume that the only factor that is involved in calculating the interest rate is the risk. So what they do is they take the prime rate, and they add it to the risk. Now the risk is dependent on various things, various factors as well. Those various factors is, number one, how has that company been performing within the years? How good is it? How risky is the business? Usually a leisure business, like Tsogosan being a hotel, is a leisure business, so usually they are higher, they are more riskier. But because of the financial records and how good they've been performing throughout the years, the risk, their minimum risk is their risk is a bit lower than usual. It's a bit lower than other leisure businesses. So I divided the loan options into 3 durations. That is the short duration, medium duration, and the long-term duration. Now the short-term duration is payable within the period of the minimum period, which is 6 years, and the risk is 3%. So you take the 3%, you add it to the prime rates, the prime interest rates, and it gives you 13.25%, and that is within 6 years. And then the medium duration, the risk is a bit higher at 4.5%. So you take 4.5%, you add it to 10.25, and it gives you 14.75%. This is payable within a period of 8 years. And the longer duration, which is a higher risk, the risk is 6.25%, which is a higher risk. And then you take that, you add it to the 10.25%, and that gives you 16.5%. And the payment duration is 10 years. Now, I wanted to show you how I calculate I want to take you to the tariff price forecast. Assuming that it is a 95% confidence interval, what I did was I calculated the average cost, the mean for both the heat pumps and the geyser systems. And then I calculated the standard deviation. And then assuming that they all follow a normal distribution, 95%, following at 95% confidence interval, 95% of the data will fall within the mean. So that means there's a 5% to account for. That 5% is the uncertainty, because 2.5% of the data will fall 1.96 standard deviation below the mean, and 2.5% of the data will fall 1.96 standard deviation above the mean. Now, to account for that uncertainty, what I did was I calculated the uncertainty above the upper bound, which is 1.96 standard deviation above the mean, which is the upper bound, and then I calculated for the lower bound, which is 1.96 times the standard deviation below the mean, which is the lower bound, and then I calculated the average between the two to get the average cost, the cost with uncertainty involved. Now, how I did this was I took, as you can see, the geysers both the geysers and the heat pumps, the costs have been going up. They've been going up. There's been an escalation going up. So I forecasted the values for the next 10 years, and then I calculated the uncertainty. Wanted to see what the uncertainty is, to involve the uncertainty, the cost with uncertainty inside, the average between the upper bound and the lower bound uncertainty. And then these are the values that I got. And then I took the values, the heat pump costs subtract the heat pump, the geyser cost subtracted by the heat pump cost to give you your annual savings from 2008 all the way to 2032. And now these values are then going to use with my inflated maintenance cost. Subtract those savings from my inflated maintenance cost to get the operational income. Now, how I got the inflated maintenance, why I did this was because these are the costs that are going to be used to maintain the heat pumps. That is, to check if there are any breakages. If there's a breakage, they have to fix it. If there are leaks, they have to fix it, and so on and so forth. Or to make sure that the heat pumps don't break, and so on and so forth. How I did was I put all the random probability, that is random numbers, put them underneath a normal distribution. So the probability was random variables, random numbers between 0 and 0.999, and then the mean, which is right here, a mean of 0.7697, which is the mean of all the inflation values from 1987 to 2017. Then the standard deviation, which is the standard deviation of those values, to get a number, a random variable and random number that is distributed, that is generated under a normal distribution. And as you can see, it keeps changing and changing, which also accounts for the uncertainty in the inflation. And I calculated my model, calculated the after-tax cash flow for all loan options, from loan option number 1 to loan option number 3. And then what I did was I calculated different NPV values under different MAR values. Now, as you can see, the one highlighted in blue is the 14.45%, which is the MAR value that we had initially for the project. And now this MAR value, I calculate, as you can see, the highest MAR value is the one of loan option number 3, which is 2,549,000. For loan option number 9 is 2,498,000. And loan option number 1 is 2,438,000, which makes loan option number 3 the most feasible loan option to go for. Now, for my sensitivity analysis, like I said, I have loan option number 1, loan option number 2, loan option number 3, and I calculated different NPV values at different MAR values, that is from 10% all the way to 30%, to see the relation, how sensitive is the NPV values for each loan option under different MAR values. How sensitive is it to the MAR value? And as you can see, the higher the MAR value, the lower the higher the MAR value, the lower the NPV. And also, as you can see, loan option number 3 is the highest, which makes loan option number 3 the most feasible project to go for. Thank you very much.